This is section 4.1, writing and graphing inequalities. So remember, when we were solving equations, we were getting one answer. Now we're going to talk about inequalities, where we're hopefully going to get a lot of different answers. So you've probably worked with inequalities before. We have less than, greater than, less than or equal to, or greater than or equal to. These are some key phrases that you can use to identify which symbol you're going to use. So if you saw a word problem that said the cost of a TV is at most $500, okay, we would know to use the less than or equal to because we had that is at most written in there for us. So a solution is a value that makes the inequality true, and a solution set is the set of all solutions. So let's figure out how we can test solutions. So we want to figure out, is -4 a solution to the inequality? Well, looking at that first one, what we're going to do to see if it's a solution, we're going to just plug it right in. So -4 plus 2, we're trying to see if that's less than or equal to -1. -2 is less than or equal to -1, which works. So in that case, it is a solution. Looking at the next one, same thing, let's plug it in. So -4 minus 5 greater than or equal to -6. -9 is greater than or equal to -6. Now that's a false statement because -9 is not greater than or equal to -6, so it is not a solution to that second inequality. Then when we're graphing inequalities, there are a couple things we want to look at. The first thing we always want to look at is whether there's going to be an open circle or a closed circle. An open circle is where the value is not included, so that's going to go with greater than or less than. A closed circle is where the value is included, so that's going to work with greater than or equal to or less than or equal to. Once you decide whether the graph is going to have an open and closed circle, we're going to pick any number we want. We're going to test to see if it's a solution, and if it does work, if it is a solution, you're going to point toward that number. Otherwise, you're going to point the other way. So let's see what that looks like with this first one. So x is less than or equal to 12. So I'm going to draw my number line, and I'm going to put 12 down. First thing, is it an open circle or a closed circle? Well, I see that it's less than or equal to, and that equal to tells me that it's a closed circle because 12 would be included. And then I'm going to pick my favorite number. My favorite number is usually 0. And I want to say, is 0 less than or equal to 12? In this case, 0 is, so I want to point toward 0. So that dot and all the numbers to the left of it are the solution set. They are all solutions to that inequality. Okay, let's look at the next one. 5 is less than y. So I'm going to draw my number line. I'm going to plot 5 and decide if it's an open or a closed circle. Well, this one does not have an equal to under it, so I know it's going to be an open circle. Same thing, I'm going to pick my favorite number, which is 0, and I'm going to say, is 5 less than 0? Well, 5 is not less than 0, so I'm going to point away from 0. So, focusing on figuring out if it's open or closed, test a value, and then decide which way the arrow points.